Alrighty, so either welcome back, or if this is a continuation, thanks for staying with me. But now that we've gone over logic pyramids to the level I want to for the time being, what are we doing in physics? Again, like I said, we went over the logic and linguistics and trying to show you the differentiation of sensorality. But in this one, again, we're just going to continue on with, we have to kind of move through all areas of physics and kind of consider the history as in addition to the actual results, the logic, or the empirical facts they say are true. In terms of like the big scale theoreticians. But I wanted to revisit the feathers and bowling ball. But really, I mean, I've made a big logical statement that vibration stabilizes into mass. And it is extremely empirically evident, but again, we're trying to show how, establish enough connections with the word sensorality to differentiate the two sensoralities and show the one, sensorality with a C, how that diction, including the actual written word, integrates into fundamental ontology, and that has to include every logical fact that has been presented by previous people. Right? The only thing that differs is one, the language, or literally the language, like Russian or English or French or Swahili or whatever, and the shape of the letters that represent those sounds. The experiences are always the same. And so, trying to find just where, again, vibration is stabilized into mass, and now we're really trying to, work out mass is inertial, right? Inertia is the resistance to the change of a state of motion. So the more massive something is, the more inertial it is. But just the concept, again, what experience made Isaac Newton or Archimedes or whoever say this word represents this physical process? That's really what we're kind of assessing. Improv derivation, just deriving out loud in real time, and trying to find relationship between these physical things. And when it comes to physics, I mean, it's there or it's not. And so that's why I like physics the most, is because you can say a bunch of words, but it has to demonstrably be true, and you have to be able to say, here's a simple proof, here's a 3-minute, or 30, not 3 minute, here's a 3-second demonstration or fact I can point out to you in a bar, and you're going to understand exactly and entirely what I mean immediately without explanation. That is what an empirical proof is. It is basically bringing to light something known that somebody already knows, and then if it's an axiom, everybody already knows it, but nobody has said it in a meaningful, formal kind of way. And by formal, I just mean demonstrably fucking true. But so we have the concept, just resistance and mass. What is resistance? What is mass? But basically Archimedes said, if I drop a bowling ball and I drop a feather in a vacuum, they're both going to fall at the same rate. And so basically effectively saying that mass, or that gravity, the force of gravity or the rate of acceleration, is independent of the object's mass. But we've made the claim, and we have a very clear historical thing butting up against each other, a rock and a hard place. Well, vibration stabilizes into energy, or stabilizes into light, which represents a certain amount of quantity of energy. And then the light stabilizes into mass. And so mass and vibration are fundamentally related. Inertia, the resistance to change can be, I guess, more general logically, but again, we're visualizing, and it's empirically true that because vibration stabilizes into mass, you kind of have to, everything is connected, but nothing is touching, and we have this tension path, again, literally a tension path, my finger connecting to my pen, which is connected to the chair, which is connected to the floor. If I bang on the ceiling real loud, other people can hear it. Right? Everything is connected, but nothing is touching because of electron mass, or because of electron charge. We've covered that, and so we've established a tension path, just a system of connected objects. And so Archimedes says, you drop regardless of the mass you drop it, it's not, the force of gravity is going to cause the acceleration to be the same between the objects. The only difference is the air resistance. And then we said, nope, mass is resistance, inertia is resistance, vibration stabilizes into mass, and so it would have to be different than the rate of change in general of any information transfer would have to be have to be more different between any two objects. And so mass is a scalar, vibration is a scalar. Let's see, like, did I just contradict myself right there? But see, that's what I'm doing, is I'm trying to figure out this is me towing the line of the known knowns and the known unknowns. It's trying to find, because to me, the word gravity is word salad. But again, because Newton established gravity as a force. Newton's kind of pick up on Archimedes' concepts. Then he says it's a force, but then Einstein comes along and says, no, gravity is a shape. It is the shape of the environment. So we've done a bunch of discussion on the geometry and on what the environment is. Again, it is the absence of matter. That is what causes shape, because mass has form. Gas does not. A closed system, a locally closed system has a shape. And so, got to do something there. And again, it just has to be demonstrably physically true. And so, because like I could say, like, this falls down, right? It doesn't fall down, it falls to the center of mass, right? If right now I'm on Earth here, the sun is here, and I don't know, Jupiter's over here, and somebody's on Jupiter right here, and the sun's right here, they're going to say down is this way, and I'm going to say down is this way. And so those are relative. We're trying to find absolutes or definitives, and we know the solution exists because of chirality. Everything is unique. All words are unique. All logical processes are unique. That's why you can say all of the wrong words and people still get what you mean, because they get your intuition and they get why you use the words incorrectly. But just trying to figure out the right words to describe that. And he also, had a big impact on the word buoyancy, the upward force of a submerged object, based on, I guess, just its pressure differential. But I'm playing around with those ideas again. It just has to get to the point where it's a definitive fact and it's new information, right? Because in the same way we use the example of the capital of South Dakota, right? That doesn't do anything new. It's great to know the capital of South Dakota. Maybe you win a trivia fact at the bar night, but it doesn't synthesize new deductions, new derivations, new derivatives. It doesn't say here's a new thing that we can say is true because of these other things that are true, independent of this one being known. And so that's what happens, buoyancy. But then we talked about, I don't know if we have, but metaphor and simile. What role does metaphor and simile have in this? And again, in our first diagram, the single fact or single triangle between two people making two different conclusions. A simile uses like or as, which includes analogies. A metaphor is scaled logic. And so when you're using a metaphor, you're not using a different, right? If I wanted to, again, you're just using stupid, simple examples, but if I wanted to pick up my pen, right? I'm an independent being, I am a tense system, right? I have tension, I can control my hands and my muscles. And so I make a decision, I fire off something in my brain because I have the ability to choose things, and I grip and pick up my pen. And so I had to go through a thought process. And that thought process was, I've been forming dexterity since I've been a baby, just like you, so you don't really move your hand, it just moves, but it's still a thought. And so you move your hand, and then you pick up the pen, and then you grab something. So in generality, move arm, grab something. Right? That logic transfers to something else. You can go pick up the carpet now. Move arm, grab carpet. Move arm, grab light. Whatever you want to do. And so that logic of move this, grab that, does not change. And then you can make that use a bunch of different words in any context. And so when you're using a metaphor, you're not using different logic. You're using the same logic scaled at different times. Because if I say, we need to extract the briefcase from the third floor of the second building in Panama at 4 o'clock tomorrow, wear red. All of those things are just adding specificity. But it's still, expansion of the general form. It is what it is. That's the general form of logic. And then and then you add specificity to derive that unique sequence of linguistics to show to a physical process. So that is, again, that's what I'm trying to do with gravity, or that's what I am doing with gravity. But you can't say what you don't know, and if I can't say it, I don't know it. But metaphor is scaled logic, and simile is like you're using a very desperate or disparate section of the logic tree. And so, at least within the set of known knowns, there's no connection between the words. Again, you can very simply say, it is what it is, or, vibration is everything, or timing is everything. Extremely sweeping. And the reason some of those phrases exist, like timing is everything, because it is true, but it's not specific enough to be meaningful or useful most of the time. And so, but it has a profound logical application and applicability. So that's going through there. And then another thing, right? Reality. What is reality? Well, now we can start looking at literally, right? Reality is literal. The word reality is a combination of the prefix re and the suffix ality. It's not an independent word. Literally. And so that is a very poignant result. And so, again, you can show the brackets. If you see my dichotomistic pairs, those are bounds. Those are logical bounds between what's represented by the sets of those words. And so what we're doing is we're demonstrating the proof of speciality through, I've already identified the form of the solution. It is what it is. And then you contract all of this logic through reality, which literally means the real stuff around you, the physical world, as well as the word. And so it is a... Re and ality are bounds, and re, right, in the English language is typically a suffix to mean, or it's always a suffix to mean to do something again. Retry, redo, retype, whatever. And so that's like you can't restart, or you can't actually go back physically in time. You can't go back to yesterday. And so you can't do things over. Geometrically, you don't have the same physical structure because of chirality. But the structure of reality is it's a condensation of logic. That's what the prefix and the suffix do. The magnetic monopole's existence, right? You can't take a magnet and cut it in half and then just get one pole, positive or negative. So that does not exist. And again, that's evidence of the stabilization of R2, right? And literally in the history of physics, we have electricity, magnetism. Maxwell comes along and says it's two different descriptions of the same thing. It is, and that's just, forget me when I'm saying the logic consolidates and you're talking at different levels of specificity. That is literally people historically documented going from thinking two things are different and showing their relationship and unifying them. So that's where the motivation of unification comes from. But in reality, you want to go to expansion. You want to expand your bank account. You want to expand your social connections, your reputation. So it's always on this dichotomy of going between specificity and generality. But magnetic monopoles not existing is the evidence of the stabilization of R2. Again, we have the descriptions of energy for R2, and then vibration for R1, and mass for R3. And so again, charge is never in perfect distribution. And so, right, like my pen moving right here induces some amount of magnetism. And you might be, no, it's not. Well, it might not be detectable. I mean, again, there's a measurement limit. If you can't take a magnet and see any sort of repulsion or retraction because I'm moving my pen, well, it's just because the field's not strong enough. And so, again, like neutrons don't exist really. There's always some sort of charge distribution, but all of that differentiation is limited by measurement. Magnetic field. Oh, but that's another, again, a well-known example is if you take, a magnet and you walk across a wire in the woods, you might think it may be a current-carrying wire, and you want to figure out if it is carrying a current. You just put the magnet up, or your compass up to, which is a magnet, up to the wire, and if it deflects the magnet pointer, it is running current, so you don't want to electrocute yourself, so you shouldn't touch it. And so that's just another example. But now I do have another diagram here, but it's not really that important. But let me pause and think if I want to put up a diagram. So I'm not going to put up another diagram because it's really simple. Just think of two squares, one going from one to the other. This one over here being R2, and this one over here being R3. This is just some sort of energy density, and this over here is the world you see around you with objects and mass and shapes and different sizes, in different densities and all of the other things. And so one scale, you just have, again, think of a static TV, buzz, 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 bunch of energy. It cools down. It allows for atoms to form as well as shapes. You have all of the irregular and irregular objects, and the physical boundary and shape of the universe is not known. Well, the physical boundary of the universe is undefined. The shape, we can definitely, if you guys haven't already figured it out. But I told you the overview of what you do. But you have a bunch of buzz, buzz, buzz over here in R2, energy that is light, stabilizes into mass, boom, and now you have the world around you see. And if you took any physics class, even in undergraduate, they'll talk about field lines. And so another piece of evidence that the correct intuition to stabilize, vibration stabilizing into mass is 1 electron per 1 field line, right? It's not like if I have, we'll just use the gravitational, we'll just stay with the electrics, right? If I have an electric field, it's not like the grid lines are shown out to me with my eyeballs, right? And so, but, right, an electron will stay, on 1 field line. And so that's really because the electron is the field line, right? A field line graph is a representation of reality. Reality is reality. And so that electron, right, kind of think of if you took a rubber band and twisted it like this. And so the two ends are really, 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 really tight, and then you still have the sphere type thing. And so that the electrons, the sphere, and the little tight infinitesimally things, again, making infinitesimally not the differential of the area, but just the indistinguishable aspects of matter, come off the side of the electron, and we're limited by measuring the electron and probing the electron by energy levels. And so, good luck proving that wrong, but that is why you have 1 electron per 1 field line right now today in taught physics at university. But, right, so you have vibration, and then you have a good visual. Again, I don't know if you can see it. I don't know if I'm going to put it up there, but just try to put it in there real quick. But I just have a line with 3 circles on it. And so this is an electron. It's at a certain temperature. Well, I guess it's got to be a group of electrons because that's temperature is between one thing. But it's sitting there vibrating. And so that vibration, when you're picturing this physically, directly, or as there's some finite or there's some amount of connection, the mass is the environment, is the electron. That's why it would make sense. It would just because it's connected. It's literally again, if you took a super long string and then you curled it up over here, and there was a knot here, but then it was flat over here, and this was curled up, and then this was curled up. You'd have different kind of curls, but they're all connected. So this thing over here is still connected to this thing over here. And so when it's fundamental physics, the temperature is going to equilibrate, right? That's why they're saying, is it going to be, a heat death of the universe, but it's really cold? Again, they're just fucking up the logical. And it's not even a meaningful question. When they say, what's going to happen at the end of the universe? Again, that's a bounded question. That is so far off in unknown land. Nobody's going to touch on that. I would say forever, but it's not a meaningful question. And so you can throw out words that sound like good questions, they're just not. But that is 1 electron per 1 field line, and the vibration transmitting the information, temperature, to equilibrate is because everything is connected, everything is the same thing. Vibration stabilized into mass, mass stabilized, condensed into matter. And so that matter is all physically connected. And so that's why temperature gets to 1 uniform thing for the entirety of the universe. That is why the cosmological microwave background has the same radiation reading regardless of reference frame, regardless of anything, because it's the infinitesimality left over from the stabilization of when there was just light. A logical correction I made, I misspoke, or I was just flat out wrong. I said that all objects are, or there's no such thing as rotational, or all motion is rotational. That's not true. All objects are moving. Nothing is at completely still. But what I meant to say is all motion is orbital motion. All objects, right, measurement limits, everything we can model everything like a point particle for now, again, at a given limit. Obviously, we have irregular objects all around us. But keeping with the tradition of physics, we'll use our ideal limit of a circle or of a sphere. But because matter is what is gravity, or like mass stabilizes into objects in the absence of where that stuff is space, and it's all circular, right? All tangents are perpendicular to a circle. All motion is perpendicular to the sphere of influence of another body with mass. And so I just a logical correction that all motion is orbital. Not all motion is rotational. Again, physics converse for that is translational as right now today. But all motion certainly is orbital, and most of the relevant things in terms of celestial bodies are rotational as well. But again, just working out, differentiating the logic so we can create a unique known. But again, we have vibration and momentum. What is the relationship? Because vibration is no movement. Momentum is the relationship of movement. Vibration is stabilized into energy, into mass. But momentum also has a relationship with mass and then to velocity. So what do we make of that? And then I just have a renormalization just to get those words in a different context. Right? Good vibes increase momentum. Go watch a basketball game. All the fans are cheering. We have the momentum. What do you mean? Like, people cheering? Is there more mass or more velocity now? Like, there's more, like, again, metaphorical velocity. We're going faster. We're feeling the good vibes. And so that's a logical renormalization. Everyone without any explanation knows what I mean when I say good vibes are proportional to the momentum, or good for momentum. We want to have a good day. Everyone's in a good mood. Same exact logical statement. But trying to figure out, I would say rigorously, but empirically, it just has to be true. And again, demonstrably, within 3 seconds at a bar, I can do something or say something, and you two know exactly what I'm saying, and you could not deny it even if you tried. So I just have what is momentum, what is inertia, bring back in another idea, entropy, right? We haven't said that word in a while, but entropy, what is the relationship between entropy and rhythm? Rhythm limits entropy. Go do anything. Literally go do any procedure. Go to the store. Go package a bunch of letters. And if you try to do something more efficiently, instinctually, empirically, you're going to form a rhythm 100% of all the time. And so very, very demonstrably and viscerally, rhythm limits entropy disorder. Entropy just being the disorder of a system. If you're a circle jerk in physics, you'll say the number of microstates, but just the amount of configurations a given system can be in. No, most generally, entropy just means total disorder of a system. The amount of free energy, our big square box with all of that vibration into light, all of that energy into light, and now we get some form, now we have energy density. Entropy is just the total disorder, right? A system with a daycare that has one child, that one child could be very disorderly or pretty calm. If you have a daycare with 100 kids, there's a lot more chance it's going to be more disorderly. But simply having 100 kids in that daycare is not going to make it more disorderly by de facto. It's not going to happen. And so assessing disorder based off microstates or based on configurations makes no sense. It's disorder in the same way you think disorder. And we have to make the physics of that match the reality of the logic of the word. And so if you have a disorder, you're crazy, you're unpredictable, but just increasing quantity, increasing the total absolute number of something by no means is indicative or causal to being more chaotic. And so, and just I have invisibility is absorption of momentum. And so, I mean that literally, you have to think about it for a second, right? If you can't see something, the light is not bouncing off of it, but now we've said that there is no light, we're just discussing this as momentum, and right, because in what's fundamentally also wrong in the previous physics developments is saying light has momentum. No, it does not. Momentum is momentum. Again, have to progress the proving there more. But the invisibility is the absorption of momentum. If light has a momentum, right? That's the visible spectrum for us. There's a bunch of other things that we classify as light, and we can't see them. It's because it's not as explained by current theory. It's not reflected by an object in a way that registers or causes a reaction in our physical body. But invisible just means you can't see it of momentum. So if it absorbs that photon and it doesn't reflect back to you, you can't see it. So it's literally invisible. You can't see it because it absorbed the momentum. I mean, it's a very literal statement. But that's what all of my logic is. And so, or anybody's logic at that. But, and again, also, I would imagine you guys followed along that, but it's the same thing as if you put you have a gallon of hot water and you put 1 drop of cold water, it's going to equilibrate the vibration. Literally, it's going to get to the same temperature. And so that's what I got there today. But again, we could also generalize the entirety of electricity and magnetism into 2 words, attraction and repulsion, which is really, we can generalize that even past force. Because, right, you can have an attractive force and a repulsive force. So you just use the words attraction and repulsion in complete generality. Again, reverting back to strong nuclear force, weak nuclear force, and electromagnetic force are a lot stronger than gravity. Well, that's because gravity is gravity, which is a terrible word. The reason other objects are attracted to the center of mass is because the mass is all condensed from the same initial conditions and then there was light, the beginning of the visible universe. And so, again, just false differentiation, things you don't need to make so specific. But I think I'm going to leave that there today. I think I've made some good, insightful points. We've done a lot of things. This will probably be a 2-episode break apart, one for the logic at the beginning, and then one for the physics. But again, we're combining it all. So who knows? I'll decide when I edit on the fly. But regardless, thank you for watching, and I will see you on the next one.